Next question. Prove that the area of triangle inscribed in a parabola y square is equals to 4ax is 1 by 8a mod y1 minus y2, y2 minus y3, y3 minus y1 square units, where y1, y2, y3 are the ordinates of the vertices. See, this is parabola and the triangle is inscribed in a parabola. Okay, so 3 points will be there in a triangle. So one point is A, that is x1 comma y1, and second point B, x2 comma y2, and C, x3 comma y3, and the parabola is y square is equals to 4x. Okay, so given equation of parabola is y square is equals to 4x, and the points, let the points A, x1 comma y1, B, x2 comma y2, and C, x3 comma y3 lies on 1, that is on parabola. Okay, then y1 square is equals to 4a x1. So we are substituting x1 y1 in this equation. So at the place of x we are writing x1, and for y y1. Okay, from this we will get x1 value. X1 is equals to y1 square by 4a. Okay, similarly for this y2 square is equals to 4a x2, x2 and y2, and x2 will be y2 square by 4a, and y3 square is equals to 4a x3 is equals to x3 will be y3 square by 4a. Substituting all these values in equation 1. Okay, the area of triangle formed by ABC is triangle is equals to half mod x1 minus x3 y1 minus y3 x1 minus x2 y1 minus y2. This is the formula for area of triangle. Half mod x1 is y1 square by 4a minus x3 is y3 square by 4a. This one same as it is, and x1 is y1 square by 4a and x2 is y2 square by 4a. This one same as it is. Okay. Now taking LCM here, the denominator will be 4a and numerator will be same, y1 square minus y3 square. Here also y1 square minus y2 square upon 4a after taking LCM. Now taking 4a common from this, in the denominator 4a was there, so taking 4a common here. Here also taking 4a common. Okay, so 1 by 4a y1 square minus y3 square. This one same as it is, 1 by 4a y1 square minus y2 square same. Okay, now take this 1 by 4a common from the first column, taking 1 by 4a column from this column, taking 1 by 4a common. So it is in the form of a square minus b square. So a square minus b square is nothing but a minus b into a plus b. That is y1 minus y3, y1 plus y3. Here also a square minus b square, y1 minus y2, y1 plus y2. Okay, same. 1 by 2 into 1 by 4a. Here, see from this row we can take this common, and from this we can take this common. From R1, that is row 1, we are taking this common, and from R2, row 2, taking this. So you are left with y1 plus y3, y1 plus y2, and here 1, 1. Okay. So taking common y1 minus y3 and y1 minus y2 from row 1 and row 2 respectively. Here 2 4 is 8, 8a, 1 by 8a, y1 minus y3, y1 minus y2. Okay. Now taking, see, do the cross multiply here. Taking determinant y1 plus y3 into 1 is y1 plus y3 minus, that is AD minus BC. So y1 plus y2 into 1. In the middle always negative sign will be there in that formula. Okay. 1 by 8a, y1 minus y3, y1 minus y2, y1 plus y3, multiply here. It will become minus y1 plus into minus minus y2. y1 y1 gets cancelled. You will get y3 minus y2. 1 by 8a, y1 minus y2, this one, and y2 minus y3. We want y2 minus y3, but we have minus y2 and plus y3. So taking minus from this, so it will become plus and it will become negative. From this also we want y3 minus y1. So Here negative y3 is there and positive y1. So taking minus from these, so you will get plus y3 and minus y1. Okay. Now these two will be multiplied and it will become plus. So this will go away. y1 minus y2, y2 minus y3, y3 minus y1. 1 by 8a mod y1 minus y2, y2 minus y3, y3 minus y1 square units. Hence proved. Next question. Prove that area of triangle formed by the tangents at x1, y1, x2, y3, x3, y3 to the parabola y square is equals to 4ax is 1 by 16a mod y1 minus y2, y2 minus y3, y3 minus y1 square units. Okay. We have to prove that area of triangle formed by tangents these to the parabola is this much. Okay. So given parabola is y square is equals to 4x and the points a, x1, y1. Here we are using parametric forms. Okay. So p of x, y is 80 square, 280. Always. Okay. This is parametric form of point. So here x1, y1 is there. So for x1 we are writing t1, t1. For this 2 we are writing t2, t2. That is a t1 square 281 and here a t2 square 282. Same formula just for x1 y1 here t1 t1 is there. For x2 y2 t2 t2 is there. Okay. x3 y3 a t3 square 2 a t3. Okay. 3 points we got. Be 3 points on the parabola. Okay. P of t is equals to actual formula is P of t is at square 280. Equation of tangent and the point P of t is ty is equals to x plus at square. This is the formula for this point. Parametric form. Okay. Equation of tangent at point this is this. So now we will substitute these values here. The equation of tangents at a, b, c are p of t1 will be t1. Here also t1. t1y is equals to x plus at1 square. For p of t2 is t2y is equals to x plus at2 square. t3y is equals to x plus at3 square. Okay, these are the equation of tangents for a, b, c. Okay. Now we will solve 1 and 2 and 2 and 3. First we will solve 1 and 2. Equation 1 and equation 2. Changing the signs minus, minus, minus. Okay. t1y minus t2y. X will get cancelled. at1 square minus at2 square. Okay. Now taking y common from this y into t1 minus t2. Here we can take a common. Okay, y into t1 minus t2 is equal to a. It is in the form of a square minus b square. That is a plus b into a minus b. Y is equal to a into t1 plus t2, t1 minus t2. This bracket value goes in the denominator and these two will get cancelled. So y value is a into t1 plus t2. Now substituting y value in equation 1. t1y is equal to x plus a t1 square. t1 y is a into t1 plus t2 is equals to x plus a t1 square. Now multiply a into t1, t1 square plus a into t2 into t1. Okay, is equals to x plus a t1 square. a t1 square plus a t1 t2. Taking this value here, it will become minus a t1 square is equals to x. These two will get cancelled. So x value will be a t1 t2. We got x and y value. Therefore, the point of intersection of tangents. Point of intersection is nothing but when we solve two equations, we get two values. So that is point of intersection. Okay, we have solved just now the tangents equation. So we got two values, x and y. So that is point of intersection. After solving 1 and 2, we got one value, that is x1 and y1. So P of t1 t2 a into t1 plus t2. This is x value and this is y value for equation 1 and 2. Similarly, the point of intersection of tangent 2 and 3. It means after solving the tangents, second equation and third equation, that is B and C, and third and 1, that is C and A, you will get these values. Okay, first we got x and y. Similarly, you will get x and y for these two equations and these two equations. Okay, so for solving 2 and 3, you just T1, T2 will change. A, T2, T3. T2, T3. Okay. For 3 and 1, T3, T1, T3, T1. Okay. Same values, only changing the numbers. Now we got 3 points. P is this, Q1 this, and R is this. Okay. This is X1, Y1, X2, Y2, X3, Y3. Area of triangle PQR is half mod x1 y1 1, x2 y2 1, x3 y3 1. This is also our formula for area of triangle. Okay, now we substitute all these values x1, y1, x2 y2, x3 y2 in this. Half x1 is a t1 t2, x2 is a t2 t3, a t3 t1, and y1 y2 y3. This one same as it. Taking common a from c1 and c2. C1 and C2 means first column and second column. We can take a common. Okay, from this column a, and from this column a into a. Okay, so this one same as it is. Now row R1 is equals to R1 minus R3 we have to do, and R2 is equal to R2 minus R3. This is R1, R2, R3. So for R1, R1 minus R3, R1 minus R3, T1, T2 minus T3, T1. Okay, and R1, T1 plus T2 minus T1 plus T3. 1 minus 1. Okay, for R1, R1 minus R3. For R2, R2 minus R3. R2 is T2, T3 minus R3, T3, T1. T2 plus T3 minus T1 plus T3. 1 minus 1. Okay, this one same as it is. We are not performing any row operation here in the row 3. Okay, only R1 and R2 will change. A square by 2, that is a into a is a square by 2. Now, taking common T1 from this, you will get T2 minus 3, 3. Here, T3 common, you will get T2 minus T1. This one same as it is. T1 plus T2 minus T1 minus T3. T2 plus T3 minus T1 minus T3. T1, T1 gets cancelled, and here T3, T3. 1 minus 1 is 0, 1 minus 1 is 0. A square by 2. T1, T2 minus T3. Same. Here these two get cancelled. You will get T2 minus T3. Here T2 minus T1. T1 plus T3. 0, 0, 1. Okay. Now from here we can take T2 minus T3, T2 minus T1 from R2 and R1 respectively. From R1 we can take common this, and from R2 we can take this common. Okay, a square by 2, T2 minus T3, T3, T2 minus T1. You are left with T1, T3, T1, T3, 1, 1, 0, 0, T1 plus T3, 1. Okay, after taking common, a square by 2, this is common. Okay, now we will find the determinant. T1, okay, T1, leave this row and column. 1 into 1 minus this into 0 is 0. Now second, 1 minus 1. Okay, we have to write minus for the middle term, minus. So leave this column and this row. T3 into 1 is T3 minus, means this column is eliminated. We have to consider these two, T3 and this into 0 is 0, plus third one 0 into, now leave this column and this row. So multiply these two and these two. T3 into T1 plus T3 minus T1 T3. but here 0 is there, so full whole bracket will become 0. 0 into something 0. Okay, a square by 2 t2 minus t3 t2 minus t1 same. Now t1 once a t1 minus this is 0 minus 1 into t3 is minus t3. This whole term will become 0. t2 minus t3 t2 minus t1 t1 minus t3. Okay, we want now t2 minus this one we got. Okay, now we want t1 t2 t2 t3 t3 t1, but here t1 and t2, t1 is negative, t2 is positive, so we have to take negative common. So t1 will become positive and this will become negative. Next t1 t2 t2 t3, here it is same, you can write it directly t2 minus t3. Here t3 minus t1 we want, so we have to make this positive and this one negative, so take minus common from these also, so you will get t3 minus t1, and this minus multiply and become plus, so this will go away. Now we can write it as a square by 2 t1 minus t2 t2 minus t3 t3 minus t1. Okay, now multiply and divide by 8a cube. 8a cube is nothing but 2a into 2a into 2a, 2 to the 4, 4 to the 8, a into a is a cube. So this 8a cube will be multiplied here and in the denominator also. Okay, we are splitting 8a cube here, multiplying with these three brackets, 2a into first bracket, 2a into second bracket, 2a into third bracket, which is nothing but 8a cube. Okay, now multiply 2a here, 2a into t1 minus 2a into t2, 2a into t2 minus 2a into t3, 2a into t3 minus 2a into t1. Okay, here a square and a cube, only one a will be left in the denominator, and a 2s are 16, 1 by 16a, we got it. Here 2a t1 is nothing but y1, 2a t2 is y2, 2a t2 is y2 minus y3 minus y1 square units, hence proved.